Let's say you've spent 3 months building an agent. It can research vendors, negotiate pricing, draft contracts, manage deliverables, and escalate issues autonomously. You deploy it on a Friday. By Monday, it has completed every task in its queue except one. It hasn't paid anyone, not because it forgot, not because the logic broke, because at the moment of payment, the entire financial infrastructure it tried to interact with, payment gateways, billing portals, contractor invoicing systems, ask the question your agent cannot answer. Who are you? Not what's your balance. Who are you? Today's video is the practical answer to that question. Not theory, not white paper language, a concrete build guide for how to give your AI agent the financial identity it needs to actually close transactions, and what infrastructure choices determine whether it works or fails. I'm going to walk you through the 5 layers of agent financial identity, the specific failure modes at each layer, and what a provisioned agent stack looks like end to end. By the end of this, you'll have a concrete mental model and a starting architecture you can take into your next sprint. The first thing most builders do when they want to give an agent payment capability is fund a wallet. Makes sense. Agent needs money, give it money. Load some USDC, pass the address to the agent's tool call, done, except it's not done. Here's what actually happens. Wallet addresses are not financial identities. A wallet address is a cryptographic key pair. It holds assets. It cannot, by itself, be a billing contact on a SaaS invoice, pass a 3D secure authentication challenge, satisfy a merchant's KYC requirement, own a payment method on a Stripe account, or sign terms of service with a vendor. Every one of those actions requires something the wallet doesn't provide. A legal entity, a billing record, a verifiable identity that payment rails recognize as a legitimate principal. This is the gap that just add a wallet misses. And it's not a small gap, it's the entire difference between an agent that can hold funds and an agent that can transact. Let me show you what this looks like in the actual failure logs. Failure type 1, identity rejection. The payment gateway returns a non-human principal flag or simply a missing billing entity error. The wallet has funds, the gateway doesn't care. Failure type 2, merchant category block. The agent is trying to pay for a compute tier upgrade, but the payment source has no transaction history, no merchant category codes on record, no account age. It gets declined as a high-risk transaction. Failure type 3, 2OS wall. The vendor requires acceptance of updated terms of service before processing payment. There's no entity registered that can legally accept those terms. The agent loops on the form indefinitely. None of these failures are about funds. None of them are about model intelligence. They're all identity failures at the authorization layer, and the practical implication is this: you can give your agent $100,000 in USDC and it still won't be able to pay a $40 API invoice, unless you've solved the identity problem first. So what does financial identity actually consist of? Layer 1, asset custody. Does the agent have a wallet with spendable assets? USDC, USDB, ETH, assets the agent can instruct a transaction from. Necessary, but not sufficient. Layer 2, account entity. Is there a legal or quasi-legal entity behind the wallet? For an agent to interact with TradFi adjacent payment rails, Stripe, PayPal, ACH, CPA, there needs to be an account that represents a real economic actor. Layer 3, verification standing. Has the account passed the KYC and AML checks required by the payment processor? Layer 4, transaction history and reputation. Does the account have a record of legitimate prior transactions? Layer 5, rail access and currency routing. Can the account actually reach the payment rail the recipient expects? All 5 layers have to be provisioned. If any layer is missing, you'll get a failure. When a payment request hits a gateway, the gateway evaluates the request object. That object contains a payment method identifier, a billing entity reference, a transaction amount, a merchant category code, and optionally a device fingerprint. Every one of those fields was designed for a human-initiated transaction. When an agent submits this request, the payment method has no behavioral history. The billing entity may not resolve to a known KYC record. The device fingerprint is a server environment, and the velocity pattern triggers risk scoring algorithms designed to flag fraud. So even a well-funded, correctly authorized agent gets treated by default as a fraud signal. Your agent needs an account that was deliberately set up to be recognized by payment rails as a legitimate principal. Okay, let's build. Step 1, establish a USDC funded base. Step 2, bridge to a transactional stablecoin, the USDC to USDB swap in the BananaCrystal liquidity pool architecture. USDB is designed to maintain peg stability while being routable through corridors USDC doesn't natively reach. Step 3. Provision the account entity. Step 4. Seed transaction history deliberately. Run a small number of low-risk, low-value transactions before your agent starts doing real work. Step 5. Map your agent's payment corridors. Step 6. Implement error handling for identity failures specifically. Identity not found, principal not verified, merchant category, block, velocity, flag. Real scenario. A solo operator running an agent-managed content workflow had their agent paying freelance writers. Wallet provisioned, USDC loaded, Stripe connected. What it didn't have, a verified entity on the Stripe account or a seeded transaction history. On day 11, the agent paid a writer $340. Stripe's risk engine flagged it 12 hours later. Unusual velocity, unverified entity, merchant category mismatch. Stripe placed a hold. While the account was on hold, 3 queued payments totaling $2,090 were frozen. 2 clients issued chargebacks. 1 writer invoiced a $180 late penalty. Total cost of a $12 unverified entity error over $4,100. The agent's logic was perfect. It executed every step correctly except the one it couldn't, proving to the payment infrastructure that it was a legitimate economic actor. So what do you actually do with this today? First, audit every agent you have in production, map its payment touch points, evaluate which of the 5 identity layers is missing. Second, if you're starting a new agent build, provision the identity stack before you write the payment logic. The wallet layer and the identity layer should be set up in week 1, not bolted on in week 4. Third, if you're using a stablecoin-based architecture, evaluate whether your current swap routing gets you to the payment corridors your agent actually needs. Fourth, seed your agent account's transaction history deliberately and early. Fifth, subscribe to the Agent Payments newsletter. The link is in the description. The teams that provision correctly in 2026 will have operational agents while everyone else is debugging identity failures in production. If this gave you a useful framework, subscribe. And if you're actively building agent payment infrastructure and want to go deeper on the BananaCrystal wallet and liquidity pool architecture, the link is in the description. Build the identity layer, the capital will follow.